When calculating standard normal probabilities using the TI-84 calculator, the only thing that's really different from the TI-83, which are in most of your lesson videos, is that the TI-84 doesn't allow you to only use the two-input version like what you saw. So when you press second and distributions, and then come down to normal CDF, and by the way, we'd never use normal PDF. We will use inverse norm at a later time, but you'd only ever use normal CDF or inverse norm. So normal CDF is what we want right now. When you press enter, it's going to bring up a menu here, and it allows you to give 4 different inputs: a lower bound, an upper bound, a mean, and a standard deviation. Now here's the thing. So here's an example problem. The probability that z is less than 1.67. So when you're looking for the probability of the variable z, that tells you that you're on a standard normal distribution. And the standard normal distribution, I'll just sketch one here, has a mean of 0 and a standard deviation of 1. That is what's meant by your standard normal distribution. So if you're calculating the probability of some z, which makes this a z-axis, that's what you'll use. Mu equals 0, standard deviation is 1. The mean is right in the center, of course. And then 1.67, it doesn't really matter exactly where you put that. It's just somewhere to the right of 0. Now, here's where this symbol comes into play. So this tells me that I'm looking for all the z-scores that are less than 1.67. So the values that are less than 1.67 would be on the left-hand side of this distribution, because like 0 is one value that's less than 1.67. So the probability that we want is this shaded area right here, and it extends all the way down to negative infinity and then stops up here at 1.67. So when you use normal CDF in your calculator, it requires 4 inputs: a lower bound, an upper bound, and then a mean and a standard deviation. All right, so the mean and standard deviation are of course going to be 0 and 1 because we're on a standard normal distribution. The lower and upper bounds, these are the values that are the boundaries of your shaded region. So in this case, the lower bound, it's negative infinity, but we just want to use, there's no negative infinity key on the calculator, so we need to use something that's really small. And I think in the videos it probably says something about using like -10 or -10,000 or something like that. But regardless, I've been coming around to just having students use -e to the 99th. So what this means in the calculator is basically -1 times 10 to the 99th power, which is an extremely large number. Much larger than you ever need, but it works in all cases. So that's why I'm going with that now. The upper bound is just the 1.67, and then of course you separate all these values with commas, but the calculator is going to do that for you. So coming over here, it looks like by default I've already got this -e to the 99th typed in, but if I didn't, it was easy enough to do. You don't actually need the 1, you can just hit negative, but be careful that you don't hit the minus, and then do second and comma, which gives you this EE, and that is the E that's used for scientific notation. It's a small capital E. So be careful not to use alpha E. See, that's a larger capital E. And that's a memory location, and who knows what could be stored in there. By default, it's probably 0, but it could be anything. So regardless, that's not what we want. And also, there's a lowercase e over here. And if you've taken an algebra course, you probably know that that's a value kind of like pi, which is like 2.718. Regardless, it's not what represents scientific notation in the calculator, so that's not what we want. So just be careful, make sure you use the correct symbol, and then 99. and that's good for negative infinity. The upper bound was 1.67, and then the mean and standard deviation, if it's set to anything other than 0 and 1, go ahead and change those back. And then when you're done, hit enter to paste that onto the home screen, and then you will have to press enter one more time to get an answer. But once it does that, this is the probability that you're looking for, and that's the total shaded area that I have right here. So 0.9525. And that would be the answer to the first one. All right, now the next one here, the probability that z is greater than negative 0.51. The only difference here is that because it's z greater than some value, this is an area to the right. And when we go to calculate this, we'll go back into the normal CDF function. But this time, because it's an area to the right, the lower bound is that value that's given of negative 0.51. And the upper bound is positive infinity. So we would do e to the 99th. Mean and standard deviation don't change because we're still on a standard normal distribution because the variable listed is z. And then hit enter for putting it onto the home screen, and then once more to run the function. So the probability here is about 0.695. Lastly, this notation right here is how we represent the probability between two z-scores. What's nice about this is that you don't have to substitute in the negative e to the 99th or anything like that. You just use the two values given. The smaller one first, and then the larger one. So second distribution, down here to normal CDF, and I believe it was 0.81 and 2.45. Yeah. So we just enter those. Because it's still involving z, that means we're on a standard normal distribution. We'll leave these two values alone, and then press enter twice to run the function. So that probability is approximately 0.208.